Hi, and welcome to Divya and Nadia's educational video on molecular shapes.
Today we'll be investigating 5 molecular shapes, the first of which is linear. So one example of a linear molecule is CO2, which is carbon dioxide, and here's the Lewis structure. And carbon dioxide has a bond angle of 180 degrees, and it has 4 shared electron pairs on the central atom, carbon. And even though it has polar bonds, it is a non-polar molecule because it's symmetrical.
The second molecular shape we'll be talking about is trigonal planar, and as you can see in this picture and this example of boron trihydride, or BH3, there are 3 shared pairs, and trigonal planar also has a bond angle of 120 degrees. Even though there are polar bonds, the polarity of BH3 is nonpolar, and it's an exception to the octet rule. BH3, or boron trihydride, is symmetrical. Our third molecular shape is bent, and our example is H2O, also known commonly as water. You can see a picture of it here. And the bond angle is 104.5 degrees, and the polarity is polar because all the bonds are polar, and there are 2 lone pairs and 2 shared pairs of electrons in this example.
The third shape is tetrahedral. One example that we came up with was the ammonium ion, NH4, and here's a picture of it here. And the bond angle is 109.5 degrees. It has 4 shared electron pairs, and it is nonpolar because, as you saw, it is symmetrical. Our fifth and final molecular shape is trigonal pyramidal, and our example is right here. It is ammonia, also known as NH3. It has a bond angle of 107 degrees. On the central atom, it has 1 lone pair and 3 shared paired of electrons, and it also is considered polar because it is asymmetrical and has all polar bonds. So, now that we've gone over all 5 molecular shapes, you've probably heard us talk a lot about polar and nonpolar. But in case you don't know what that means, I'm here to help. So first, polar is when the atoms, the electrons of the 2 atoms in a bond are not shared evenly, and polar bonds form when there's a difference between the electronegativity values of the atoms participating in a bond, or when there is a positive charge on one side of the atom and not on the other, which happens when the electrons are not shared equally, because if you take electrons away from the atom, it becomes positive and more negative on the atom which took the electrons. So then nonpolar is when the electrons between 2 or more atoms in a bond are shared evenly, and in a nonpolar bond, there is no negative or positive poles are formed, and all of the electrons are shared evenly.
All the charges are shared evenly
between the atoms. So
across the molecule.
What she said.
So to determine if something is polar or nonpolar, you first have to evaluate the bonds. To do this, you find the electronegativity number of all the elements and subtract each of them by the other electronegativity numbers. If the difference is over 0.4, then it is considered polar, and if the difference of all the bonds is over 0.4, then you must evaluate the symmetry. The molecule must be asymmetrical and contain equal bond angles to be polar.
Another important thing that ties in with the molecular shapes and the polarity and everything is something called the VSEPR theory, which stands for valence shell electron pair repulsion. And this theory basically predicts the geometry of and the shapes of molecules based on the molecules' valence electron pairs around the central atom. And the electrons around the central atom arrange themselves as far apart from each other as possible, like as far away as possible from each other. The lone pairs actually repel the most, and then and remember the lone pairs are unshared. They are just two dots for one atom. And then the paired chairs have opposite spins, so they take up less space compared to electrons that are surrounding only one atom.
There's also two other molecular shapes you need to know, and the first one is octahedral, and the example we have is sulfur hexafluoride, and here are the two pictures of the two subsets. So this is our second example of bromine pentafluoride. So these are just the pictures of the two subsets and the shapes. The other molecular shape you need to know is trigonal bipyramid. So we have an example of chlorine trifluoride and an example of a triiodide ion. Thank you so much for listening to this educational video on molecular shapes.
I hope you learned something. Have a nice day.